Efficacy of peat and sulfur as soil supplements to increase Penicidum glaucum plant biomass by John Kelly Perkins, 8th grade, Brookhaven, Mississippi. Pine forestation and pine tree farming are a very large part of both the ecology and economy of Mississippi. Agriculture in general plays a very big role in Mississippi's ecosystems and economy. Farmers in the U.S. now use pesticides and herbicides to combat pests that can damage crops and affect crop yield. The problem is that herbicides and pesticides are detrimental to non-targeted animal and plant life in woodland ecosystems around the crop growth due to runoff. Runoff from chemically treated farm fields affects pine growth by altering the soil pH of their habitat slightly below normal, or 4.5, because when pesticides are mixed with acidic water, the effectiveness of the chemicals is enhanced. This runoff affects timber farming as well as those chemicals bleed into water supplies feeding timber farms. Stabilizing the pH of the soil in pine forests surrounding the farms and on the timber farms themselves increase yield and tree size, both protecting the woodland ecosystems and enhancing the productivity of the farms. Peat moss is an inexpensive additive that decreases pH and increases the ability of the growth medium to hold water. And sulfur is a cheap additive that lowers the pH of the soil. These additives can be easily obtained and can be inexpensively distributed. This experiment will determine what amount of peat moss or sulfur, when added to sand, produces the largest above-ground plant mass. The purpose of the study was to find out what amount of peat moss or sulfur, when added to sand, produces the largest on average above-ground plant mass. To model pine trees, Penicidum glaucum, a grass commonly known as pearl millet, was used. An experimental group was created made up of 6 repetitions of increments of 10 grams per kilogram, 20 grams per kilogram, and 30 grams per kilogram of both peat moss and agricultural sulfur, respectively. 38 pots were planted with 2 kilograms of sand and 25 seeds each. Sand was used as a growth medium because sand cannot contribute nutrients to the plant. The plants were grown in a greenhouse designed and built for this study. Each day for 90 days after planting, every pot was measured and recorded for weight using a Tomba 3,000 gram scale, and if needed, water was added in milliliters to bring the weight back equal to 2,500 grams. The pH of each pot in the experimental group was measured and recorded once a week with an Apper Instruments pH 60 monitor and pH 60S spear probe. Every day, the height of each pot was measured and recorded for the tallest blade. Once a week, the tap water was replaced with Miracle-Gro water-soluble all-purpose plant food at a rate of 1.5 teaspoons per gallon of tap water, or 1.7 grams per liter of tap water. The final weight was measured and recorded after 90 days was over with the American Feinstein HTP 312 electronic balance.
What you doing?
These pots, 33.
You have to weigh all 33 of them?
All 38.
And which one are you on?
33.
Are you adding water?
Well, I'm weighing this and then putting it into my spreadsheet. $23, $56, $23, $56. And then you take the pot, and then on the spreadsheet it tells you how much water. The results of the experiment were that when 10 grams of peat moss is mixed and added to 1 kilogram of sand, the greatest amount of above-ground plant matter was produced with the lowest pH and the tallest height. This graph shows the average dried above-ground plant matter. This graph clearly demonstrates how 10 grams per kilogram of peat grew the largest plants. This graph supports the claim that peat is more effective than sulfur to increase yield of crops. This graph backs up the claim. Although it grows taller, peat does not require more water. This graph further breaks down the previous graph to the increment level. The issue of chemical runoff from farms producing pine trees, cotton, grain, soybean, and other produce is a significant issue in Mississippi because chemical runoff bleeds into surrounding ecosystems, into nearby farms, and can impact the ecology of the woodland forest and the economy of tree farming. I wanted to find a solution that would protect the woodlands and support the timber industry as well. I chose to experiment with both peat moss and agricultural sulfur. Peat moss is an inexpensive additive that decreases pH and increases the ability of the growth medium to hold water, and sulfur is a cheap additive that lowers the pH of the soil. My initial hypothesis was that 30 grams per kilogram of sulfur combined with the growth medium would yield the tallest, heaviest plants with the lowest pH content compared to other sulfur experimental groups and the peat experimental groups. Using my data, I found that the experimental group that combines the growth medium with 10 grams per kilogram of peat yielded the most successful plants, which contradicts my original hypothesis. 30 grams per kilogram of peat, while being chemically similar to 10 grams per kilogram of peat experimental group, 30 grams per kilogram peat produces shorter and lighter plants, most likely because the plants were effectively drowning in the sand. Soil test results indicate that where 10 grams per kilogram of peat moss was added, the organic matter content and cation exchange capacity is greater than that of 10 grams per kilogram of sulfur. This increase in the amount of organic matter in the soil greatly increases the growth medium's ability to hold water and nutrients due to an increase in cation exchange capacity over time. This results in a greater weight of above-ground plant matter. Thus, peat combined with sand in a mixture of 10 grams per kilogram may be a possible solution to pH changes in the soil caused by pesticides used in cotton production, used in cotton, pine, grain, corn, soybeans, and other products commonly farmed in Mississippi that threaten woodland ecosystems and hinder pine tree farming yield. This experiment concluded that the peat moss with 10 grams per kilogram of peat per kilogram of sand grew the largest plants on average. This mixture also had the tallest height on average, as well as the most suitable pH for pine tree growth, 4.5 on average. Therefore, it can be deduced that adding 10 grams of peat per kilogram not only significantly lowers the pH, but also increases Penicidum glaucum, a surrogate for pine productivity, making it the best additive to increase the growth of Penicidum glaucum. So it will have a similar effect on the growth on pine trees and their habitat. I would like to personally acknowledge Dr. David J. Lang, Professor of Agronomy at Mississippi State University, for testing the plant samples and taking the time to answer the many questions I had for the study, as well as Ms. Leslie Hood for her support and guidance.